Example 143. A product reliability study was conducted on laptops by the company Square Trade Inc. Among 11,500 entry-level laptops priced between $400 and $1,000, followed for 1 year, 541 malfunctioned. Among 9,300 premium laptops priced over $1,000, followed for 1 year, 391 malfunctioned. Use a 1% significance level to test the claim that the incidence of malfunction is higher for entry-level laptops than it is for premium laptops. Does it seem that spending more money on a laptop will offer you some protection from the inconvenience of a malfunction? All right, this 1% significance level here to test the claim, that line tells me it's a hypothesis test. Now, once I know it's a hypothesis test, the question is, am I comparing means or proportions or variances? Which one? Or I read the statement here, it says that the incidence of malfunction is higher for entry-level laptops than for premium laptops. The incident is like the incident rate or the rate of malfunction. So that's like the proportion or percent. So it's not a hypothesis test about the mean, it's about the proportion. So we're going to run our hypothesis test, and as usual, whether it's for mean or for proportion, we have to come up with a claim. So let's talk about the claim here for this problem. The claim here is that the incident of malfunction or the malfunction rate is higher for entry-level laptops. So I'm going to say this, I'm going to say the proportion for entry-level, I'll use E for entry-level, is greater than the proportion for premium laptops, so I'll use P for premium. So proportion here is going to represent proportion of malfunction, right? So for entry-level laptops is greater than for premium ones. Okay, now we'll do the null and the alternative like we always do. Looking at the symbol in the claim, we could say that the alternative hypothesis is the same as the claim in this particular case, and therefore the null hypothesis must express the opposite idea. Okay, so there's our two statements. Now we have to look at our data. The data that's given in the problem is a little bit different here because it's a proportion problem. So when I look at the data, I'm going to see that the sample sizes are going to be quite large. And the first one they give me is for entry-level laptops. And since that's what I put in my claim first, I want to be consistent and use that in my data set as well first. So I'm going to say my N for entry-level is 11,500. And then they go on to tell me that 541 malfunctioned. That's the number that malfunctioned. We call that X because that's the number that had the trait that this proportion represents. This proportion represents a malfunction rate. X is the number that malfunctioned. That should be consistent. All right, and then from there, they go on to tell us about the premium laptops. And they say that the premium laptops, we had a sample size of 9,300. And it tells us that among those, 391 malfunctioned, so 391. All right, and then they lastly tell us that we have a 1% significance level in the problem. And that's all they've given us, right? So the data is not too involved here, some pretty simple things. Now, from there, we're going to take that and we're going to calculate something called p-hat. The p-hat here is a pooled estimator of the population proportion. So we're not doing, separate p-hats for each group necessarily. That's not what we're thinking of, although we will do that as well. But what I want to do first is to come up with this pooled estimator of the proportion. The pooled +estimator is this special p-hat formula, and p-hat is going to be defined as x1 plus x2 over n1 plus n2. So all this is it's basically collecting all the malfunctions together on the top and dividing by the total sample size. So it's getting the overall malfunction rate for both. And this is because under the null hypothesis, we have the possible condition that the proportions are equal, included in that statement, right? It says less than or equal to, so that means they could be equal. And if they could be equal, in the null hypothesis, we're going to run the test assuming they're equal, and we're going to actually pool these together because the assumption is what? That in the null hypothesis, which we always assume to be true initially, the assumption is that these guys are equal. So we'll collect one overall malfunction rate or proportion of malfunctions. And that's how you do hypothesis testing for the proportion. You always have to calculate this quantity. All right, so let's do that quickly. We'll have 541 plus 391 over 11,500 plus 9,300. Okay, so with that done, let's get the decimal answer of that. So when I plug it in, it'll be on the top. I'll use parentheses, 541 plus 391. close that up. And then afterwards I'll divide by, again, parentheses, 11,500 plus 9,300. Close it up, hit enter. And it gives me a value that's approximately 4%, right? So we'll say 0.0448, and I'm going to round to 1 here just to round it off a little bit. I'll actually store that in my calculator though, so I have it for later. So I'm just going to store that so I know that I have it for the next step. We're going to need to come up with something called Q hat as well. Q hat is just the complement of that P hat quantity we just calculated. So I'm going to do 1 minus that. So 1 minus 0.04481. And since I saved the whole thing in my calculator, I can just do this, 1 minus the value I stored in my calculator. And I'll get the answer is approximately 0.95519. That's my Q hat. And again, that's just the complement of the pooled proportion. So, roughly 4% of them malfunction in the total sample size altogether. So about 95 or 96% of them did not malfunction. Okay, so we have those two numbers. Our next step then is to do the sample proportions for each of these groups. So for E and P, right? So we're going to have P hat for E. Now this is just the sample proportion for the E group or the entry-level group. And then we're going to have the sample proportion for the premium group. Now for this group, we're just going to divide these two numbers here. So 541 divided by 11,500. So 541 over it's the sample size, 11,500. That's going to tell us what percent malfunctioned in the entry-level group. And then likewise for the premium group. Okay, so we have a lot of calculations here in the beginning, but if we do them now, it'll save us some work later on, right? So 541 divided by 11,500. Okay, so we get approximately 0.047, right? And then we'll do the same for the other side. So we'll do 391 divided by 9,300. And again, I'll round it to approximately 3 places. That's going to be 0.042. So if you look at it, it's, about 4.7%, about 4.2%. So it's a little bit lower on the premium laptops. The question is that significantly lower, enough to justify the increased price. To find that out, we're going to run our test, calculating our test statistic. So all of this was kind of the data step. We did a lot of little calculations there, but the reason why we did that is so when we used our test stat formula, it would be nice and easy. So here's our test stat formula. It'll be a Z formula because we're trying to approximate the distribution here by the normal distribution. So we'll use Z. And then what we're going to do is we're going to put the entry-level group first because you notice we were consistent in the claim, in the data, and then also in the formula. So we're going to have rho hat, their sample proportion, P hat for the entry-level laptops minus P hat for the premium laptops. And then we're going to divide all of that by this complicated square root. And the square root is going to be P hat Q hat times 1 over N for the entry-level group plus 1 over N for the premium group. Okay, so that's our formula. Now let's plug the numbers into that formula. So we'll plug in the P hats and then put in our P hat and Q hat that we calculated earlier. Okay, so Z equals to, the difference on the top here is going to be 0.047. That's just the P entry level, right? P entry level, or P hat entry level, pardon me. And the P hat for the premium is going to be 0.042. Then we're going to divide all that by the square root of, and in the square root we're going to put these numbers that we calculated, right? So 0.04481 times 0.95519, and all of that will be times 1 over the entry level N, which is 11,500, plus the premium laptop N, which is 9,300. Close that up, and that's your test stat formula. So it's quite long and a little bit ugly to write out, but let's go ahead and finish it up then. So we'll have the top part, 0.047 minus 0.042. Close that up, then divide by the square root of 0.04. Now I actually put this in my calculator as x, so I could have just typed in x and then 1 minus x, but I'm just going to type it all in just like we have here. So 0.04481 times 0.95519, and then times, and now we want to be careful, use parentheses again here, just like you see here. So 1 divided by 11,500 plus 1 divided by 9,300. Close up that parenthesis and then put one more closed parenthesis for the end of the square root there. And when you hit enter, you get the answer 1.73. So our z test stat is approximately 1.73. All right, now that we have our test stat, you know what's next. It's time to do the critical value. In order to do the critical value, we're going to draw a bell curve. And on that curve, we're going to label a tail. Because HA has a symbol that points to the right here, it's a greater than symbol. That means it's a right tail test. So I'm going to go ahead and do that in my drawing. I'm going to say bell curve here. A tail on the right-hand side. How much alpha is in that tail? Just 1%, right? 0.01. So we're going to go to our table now, and we're going to look up 0.01 in one tail, and we're going to find our corresponding critical value, or our z-score. All right, so let's go to the table and do that now. Remember, we're looking at a z critical value, so we're just going to go to the table in the 0.01 column on the t-table and go straight to the bottom to find this value. So let's go do that now. Okay, so we're looking in the 0.01 column and going straight to the bottom to find the corresponding z-score. And when we do that, we see that it is 2.326. 2.326. Okay, so we found the answer 2.326. And then from there, we want to just place our test stat on the curve and see where it lands. So when you do a little drawing here and see where that lands, it actually lands here, right? On the number line here, it lands before the 2.326. So the fact is we do not reject in that case. So do not reject HO, do not support HA is going to be our overall conclusion. So let's just pencil that in up here, right up next to the claim. So do not reject HO, and then that means do not support HA. Do not reject, do not support. Now, what's our claim here? Is it HO or is it HA? Well, I think it's pretty clear that the claim has a greater than symbol, so it is HA. And so we're going to be wording our answer to say that we do not support the claim. So we don't think it's worth it to buy a premium laptop. It doesn't seem like it gives you that much protection, at least in the first year, because this study was for 1 year long. At least in the first year, it doesn't give you that much extra protection from malfunction. So if you're just worried about the malfunction issue, then buying the more expensive laptop doesn't seem to improve your ability. So the answer to your ability to avoid the malfunction. So reading this last sentence, does it seem that spending more money on a laptop will offer you some protection from the inconvenience of a malfunction? It seems like not really. There's not a significant difference between the two. However, this test stat isn't super small. So the idea is, perhaps if we had used a different alpha, maybe we would have been able to say there was a significant difference. So at this point, you could say, well, under certain alphas, like alpha of 0.05, where you would end up having the critical value be 1.645, this would actually be in the rejection region then. So this is kind of, in a way, a case where it's dependent upon the alpha. So it's not super clear cut. Maybe perhaps another study or two would clear up the issue. And, or maybe extending the time out. So after 2 or 3 years, does a premium laptop malfunction at a lower rate at that point? Maybe the entry levels start to break much sooner than the premiums overall. And so that after 3 years, maybe these numbers would be quite different. So anyway, a lot of things to consider, but at least officially for this particular test, we say we do not support the alternative hypothesis at the 1% significance level. So we cannot say that it's worth it at this moment to buy a more expensive laptop to avoid malfunction.